Okay, so I guess there are only quite a few people. Yeah, pizza party, obviously. Um, I wish there was a place open so we could go, but it would be kind of awkward, I guess. All right. So office hours, problem solving. What? I didn't hear
I know
you.
you can. I making a joke about
Yeah.
figuring out the something.
The what?
It wasn't homogeneous. It was
The homomorphism?
homomorphism.
Homomorphism? I actually looked at a proof this morning for that.
Wow,
And I
nice.
brained it. So
It's actually very easy once you understand what a homomorphism is. So
Yeah.
because it's a one-to-one correspondence, right?
yeah,
Interesting.
yeah. Okay, cool. So let's do some problems or answer questions about P set 2 or whatever you guys want to do.
If nobody has a specific question about P7 2,
Yeah.
I was just wondering if you could, you know what? First, I'll look at the solutions for P7 1.
Yeah.
I was just going to do for further clarification, but I'll check that first before I was different.
Yeah, P set 1 solutions are up, so that's good.
I'm looking at the PSET 1 solutions and I'm still a little fuzzy on the addition verification.
Uh-huh.
Would you be willing to go over that a little bit more?
Yeah. So let's just look at some non-trivial addition.
You guys just really must be way over there.
We like our spot.
We
It's the
are.
perfect distance.
Oh boy.
Sorry to interrupt.
No, it's fine. All right. So yeah. So here's so this is from P set 1. So we didn't give the solution of what I was suggesting, which was to reverse the strings and to work with the reverse, which means that you're reading from, in this case, right to left. Well, because the DFA that you're supposed to, or anything that you give is supposed to read left to right. So what happens here? If we're reading this way, left to right, if we see something that's wrong, so like, is 001 a valid addition? No, it's not a valid addition. But if we have a 001, what must have happened? There must have been a carry in order to produce that 001. So we don't immediately reject at this point. So then we see, okay, if we had a carry, it must have been what is called a borrow from the next guy down. So if we see that 110, that produced the carry, then we say, okay, that produced the carry, then if we continue further, now there's no carry. Because at any point, there can only be a carry 0 or carry 1. There can't be 2 carries.
Right.
So if we see something that looks like this, 001, there must have been a carry from the previous guy. But it may be the case that, let's see, if we have 111 here, then that must have meant that not only did the carry come from there, but there was a carry for that guy. So then we keep going back and back and back until we see that the carry has been resolved. Or there was some, like if it was like this, then we'd see that there must have been a carry that came from on the third character, but we realized that since 011 is a valid addition, that couldn't have caused a carry. So therefore, this is an invalid addition. Yeah, it's a backwards way of thinking of it.
Okay.
Yeah, but going the other way is totally fine.
Okay. So basically, what I was getting confused by was the whole the strings that involve the carry and how to implement them as transitions into what states
Mhm.
Okay.
Yeah. So if you're doing it in the borrow sense, you're looking for the borrow. And if you're looking for the carry, you're carrying the carry forward across the input. Yeah.
So for the reversal proof, was it enough to say that because of regular,
Regular expressions?
oh, no. I mean, it's the reversal thing. It was like if the language is regular for the way going forward, there must exist an equivalent DFA going backwards. Is that
Not necessarily.
not necessarily?
There is, but it's not just enough to say that.
Okay.
Because, so we can go through a proof of reversal.
Yeah, can we do that?
Yeah, sure. Yeah, so this is actually a pretty interesting proof. So if we have a DFA D for L, then we want to make a DFA. I'll actually go over two proofs because the second one will actually be a lot easier. A DFA, NFA, whatever for the reverse of L. So the language that just has the strings reversed. So what would be an idea if we have a DFA already to make one for the reverse?
It could have the same states, right?
Well, I want to work with the same strings but in reverse order.
Oh, so focus on the strings, not necessarily the.
Yeah, it's just the language that has the strings in reverse order. Can I make a DFA for it?
Swap, what was an accept state a non-accept state?
That's for complement though.
Oh, okay.
So it's probably more like the indices of the inputs, right?
Yeah, so if, I'll define it formally. Let's do that. So if W is W1 up through Wn, then the reverse of W is Wn minus 1 up to W1. Then L of R is just the set of all reverse strings that were originally in L. So take everything that was in L, do the reverse operation, put it in L of R. Okay? So what would be an intuitive idea? I have a DFA for it. What would be an intuitive idea to get reverse?
Could you flip the,
All three of you were saying the same thing. So
flip the transition?
In unison.
flip the transitions, right? So that seems like a good idea. What's a problem that might arise?
We don't-
Well,
How do we notate that?
actually, we'll have, you can say it informally, but here's a problem that may arise. Let's see. Could we have a situation in the original DFA that looks like this?
I see. Yeah. One state.
Then if we flip them, then T will have multiple transitions on the same symbol. But that's okay because we can it'll just be an NFA at that point. But there's another problem that may happen. Well, where should I start reading the input? Well, in the original DFA, I start at the start state. Where do I start here? At a final state. How many final states could there be?
Could do make a new start, epsilon into all the finals.
Exactly. So if we have the situation of final state, final state, final state, well, and they have transitions coming in, whatever, and they do stuff to some other state maybe, well, what do? We make a new start state. And what do? We epsilon our way into the original final states. So should these final states now be final or not? No. All right. But where should I accept now? At the original start state. So now make original start state final.
Couldn't you also just add a new state, make it final, put an epsilon transition from the
From what?
old start state to just the new final state or no?
I mean, that'll accomplish the exact same thing.
Okay.
Yeah, that'll accomplish the same thing. Well, what did I just produce? I produced a NFA. Well, let's just check. Did we actually, if we got a computation before, do I have one for the reverse computation here? Well, if I have a computation before, it went from some start state to the final state over here. Well, the reverse of that starts at this new start state. Epsilons to non-deterministically chooses which of the final states we originally ended at to start now. Then we do the traversal in reverse order to the only final state, which is where we started before. So it is a reverse computation. So it is this is a completely valid thing. So we had to be very careful in saying that we can't just flip the transitions because the in degree of the vertex doesn't necessarily equal the out degree, and the labels don't necessarily work. And we may have more than one final state. So, and we had to make the original start state final. Does that solution make sense? All right, so there's a much, much, much easier way.
Great.
Yeah.
Great, I said great.
Oh, I thought you said wait. All right, and it's using regexes. So what do? If the regex is one of the 6 definitions, can I make the reverse of that particular definition? So if R is a regex for L, then if R equals a single character, then I'm just going to put rev of L to mean, rev of R to mean the reverse. If it's a single character, what's the reverse of a single character? Easy. If R is the empty string, then what? It's the empty string. If R is the empty set, this is empty set. Easy. If R equals R1 union R2, yeah, it should be the same because the union of 2 languages, if we have the reversal of them, then unioning them together doesn't do anything. It's just union of them. So this is just the reverse of R1 union the reverse of R2. Yeah, you have a question?
So does epsilon have a length?
No, it's the only string that has exactly 0 characters in it. Mm-hmm. So these are the tricky ones. So if R is R1 concatenated with R2, then what should it be here? R2 reverse, then R1 reverse. This was almost an exam question, actually, but I decided against it. All right. Because if you take 2 strings and you reverse them, well, the end of the second one is now going to be the beginning of the first part of it. So it's the reverse of R2 then R1. But then if R equals R1 star, let's see. I'm actually not exactly sure, but I think it is. It's reverse star. Yeah, I was trying to debate, was it star first, then reverse? No, it's reverse, then star. So reverse of R1 star. And why is that true? If we have a string that has, so this is like W1 is part of the string. It's like the first iteration through R1, W2, and it's broken up into, say, n parts. Then the reverse of this thing is Wn reverse, and then Wn minus 1 reverse, etc., W1 reverse. And so that is the original string, but reversed. So we reverse first, then we do star. No.
So you're talking about the substrings themselves would be reversed.
Yes, and the order's reversed.
In the orders. Reversed.
Yeah.
So like, okay.
Yes, but yeah, this is tricky.
Good thing it was someone.
Yeah. Let's see. If reverse of R1 makes each of the reversals, but it's, yeah, so it makes the individual strings, but it's not the reverse of the string. So I think you need an extra reverse out here. No. Yeah, I think it is R1 star, then reverse.
Which makes sense because you want the
Yeah.
WN to be in the
Yeah.
front.
Yeah, it should be that way. Unless I make a mistake and I get 10,000 dislikes on this video when it goes up. But yeah, I'm very sure that it's R1 star, then reverse now that I've thought it through. I said it was easier, but yeah, but the first 5 cases are definitely easy because it's just the inductive cases, then union, and then reverse for concatenation.
So then it looks like then we could apply any sort of function with the regular expressions and come up with a set of rules.
As long as you can imply inductively, yes. Yeah. Yeah.
Means n plus 1, right?
Yeah. Inductively, if you can apply it for the 3 base cases, then for the 3 inductive cases. Yeah. Pretty much every single property is closed for regular languages that you can think of. I actually don't know of one that isn't. I know some that are not closed for non-regular languages, like homomorphism, for example. So, yeah, we'll see some properties that are not closed for certain languages, like context-free languages, for example, are not closed under complement or intersection. But we'll see that eventually. Cool, that was a good problem, actually. Any questions about those two? Other questions in general?
I felt like, and after I'm reading the solution for it, like, spent a lot of time with I believe it was problem 5 on problem set 1, which is basically the, what was it, Mealy machines?
Yeah, it's a Moore machine.
A Moore machine, okay.
Yeah, there's a very slight difference, but I believe they're called Moore machines.
Well, it seemed like when we were discussing in the with the TA that saying when it asked to prove that the palindrome, or no, whatever the fixed point string.
Yeah.
On the fixed point string, that's where your output is the same as your input. It seemed to me like it was like intuitively obvious that it would be possible, and then by just saying, well, I can create an NFA where every transition is also that same label.
Yeah, that's enough. Yeah. That's
enough.
Yeah, that's enough. Just describe the process. Yep.
Okay.
Yeah. So the reason is that since it's a DFA underlying when it's reading the input,
Right.
it can only do exactly one thing.
Yeah.
On the transitions. So therefore, since there's only one computation for that thing to be outputted correctly, to be exactly the same as the input string, it has to be the exact same label all the way through. So therefore, you could just delete any transition that isn't the same.
Right, okay.
Yep. Yeah, but that is the strategy to do it.
Okay.
Yeah, just delete any transition where it's different.
But that didn't seem to be a acceptable answer when we were in there, as in perhaps we weren't describing it mathy enough? Or
as long as you outline a general procedure and have some form of correctness, that should be at least most of the points.
Okay. You know what I'm talking about, right?
Yeah.
That's exactly what we said in there. Just make one where the transition is the thing, and then they were like, "No, that's not. You're almost there."
Yeah.
Make a tuple, right, to make it more mathy, right?
Yeah.
All right.
Yeah.
Cool.
Yeah. It should be in the solution.
So we had it right.
Was refusing to ever say yes.
We went in there, and I was for sure my solution on 5. I was like, I've got this down, and it was what I described, and I left feeling like I was wrong. And maybe it was just the case that he wouldn't say like, yeah, that's correct. But we'll have to see when I get the grade back. But I then changed kind of my entire thing, and it's like, oh, he was right at the beginning.
The verification is the important step.
Yeah. Which,
because anyone can just give any old solution and be like, oh yeah, it's correct. It's intuitively right. But
well, I guess that's just the difficulty in saying Well, example, like how, I guess because you can't just create an example, right? If I just said my
Yeah.
transition outfit is AB and my sigma is AB, so therefore I can create one where A is good, A is B is B.
It's always a great idea, along with your solution, to give an example, but it's not a substitute.
Because because that's, I
Yeah.
proved one case, but not all of
Yeah.
them. All right.
Oh, so it's
Yeah, examples with your actual general method is actually preferred, but it's not necessary at all.
Your base case.
No, it's like if your method was totally wrong, but then you got like the actual picture correct, then it's like, okay, you should earn some partial points. Yeah,
Okay. Cool. Thank you.
yeah, writing down ideas and doing what is it? As a sanity check on a certain example is a great idea. Yeah.
So, I mean, I feel like I was prepared for this exam, but I didn't have enough time.
Mhm.
So, like, obviously, repetition
Yeah.
definitely gonna be the key.
Mhm.
But like, in the bonus problems with the problem set, is it possible? Like, I mean, I guess I haven't done math, but is there any other opportunities? I guess never mind. I'm just like, it's not the end of the world right now. Right at the end of this.
Well, let's see. Problem set 0, I had 5 bonus points. Problem set 1, I have 10. The test had 15. The second test will probably also have 15. The final will have 30. I mean,
Okay.
in each 10 points is a percent,
Okay. So-
effectively.
So the bonus points from our homework one will go added.
Yeah. All points are exactly the same. Yeah, and yeah, everything's out of 1,000 total.
And if the midterm grade wasn't too good.
Yeah. If you do better on the final, percentage-wise, it replaces the midterms
Oh, that's a rule.
Is it
because it says it in the syllabus.
So wait,
Does it replace?
Read the syllabus.
I read it.
What?
I read it. I read it.
Both. It replaces.
It's a pass-through.
It's harder to say this than what it actually is. It replaces midterm 1 if it's higher. It replaces midterm 2 if it's higher, independently.
Oh, cool.
okay.
Yep. So it's the best possible thing.
So if we get 100 in the final, then.
You get 100 on midterms.
Oh.
Yeah.
So
I doubt anyone's getting 100 on the But
Don't bank on that.
but we'll see.
So if we do great on this one, which is not the case, but I don't know.
Cool.
I will read the syllabus
Yes.
again and comprehend
Quite a few people should read the syllabus, frankly. Other question.
Can we ask questions about?
I guess that's fine.
So I think it was question 2, but it was one where the DFA and it was like part C.
Mhm.
I wasn't really sure what it was asking.
It said symmetric difference
Yeah.
of the two, and it actually gave a definition of symmetric difference. So what is symmetric difference?
it.
Just-
It is exactly 1. So how do you find in the product DFA which ones were exactly 1 of the 2 coordinates was the final state?
No.
Just look in the original DFAs. If exactly 1 of the 2 things was a final state, make that guy final. Otherwise, don't make it final. Yeah, we covered this when we covered product construction.
Yeah. It's really short.
Yeah.
Sort of a side note, I would have appreciated more room to write on
I had, so, do you want me to tell you about my experiences using the printers?
I can only imagine.
the exam.
So what I tried to do is we have a printer that's in a room for TAs to be able to print. Well, it was jammed, so I couldn't use that. Then what I decided was I know that there's a printer on where my office is, so I tried to connect to that. I can't connect to it. So then I tried to print to a printer that's not meant to print this many pages, and it works. So, and it was 8.5 by 11 pieces of paper, but I mean, I did all I could, really. If you guys can give me more larger pieces of paper, I can use those, but I don't have access to that. I could give an extra piece of paper for scratch work.
Yeah, would that be,
Yeah. So I'll make a note of that.
or if we,
Or even a
or
pile
if
of
we can,
blank paper at the door
yeah.
where people just grab, limit themselves to like.
Yeah. No, if we do this, then the scratch paper will not be graded because then we would have to hunt it down. Yeah. The back of the last sheet was scratch work. I figured that was enough, but if people need more, I can certainly give another piece. Yeah. 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 I recommend either starting small or using some of the other space. Yeah.
Like around
Yeah, I try. Yeah, I did the test myself, and I thought it was fine, but some people write differently. That I totally understand. So.
I have to get a better pen, like ballpoint
You need
thick.
Yeah.
0.2 millimeter.
Yeah. You need an.
It's not available.
You need one of those machines that lays gold out on maps. For Adam.
Yeah.
Yeah. I'll need an electron microscope to
When
read.
you use the CAD program
Could we just do another pumping lemma type of a problem?
Yeah, sure.
Just because that's going to keep coming up, right?
How'd you
It's
guys
gonna
do
be-
What?
And more complicated too.
Yeah.
I picked I as 1 the first time and I was like, I know.
Let's see.
I should have thought about it because
Oh no! I just realized I took all the notes in the wrong.
when I saw this, it was like,
What was it? Which one? Yeah. What is it? I mean, I can do one from an old midterm. Because I do remember that one.
I noticed some of the examples I saw online. They actually chose particular strings,
Mhm.
right? And then they showed a string that didn't work. Does that? I'm worried about that because does that show all cases, or
You just need to pick one string such that no matter how you decompose it, it'll pump out.
so you go, okay, that's okay.
Yeah, and yeah, you can pick any string because it says for all strings in the language, they can be pumped.
Okay.
But if you find one counterexample that counteracts the for all statement.
But it's how you can decompose that
Yeah.
string.
Yeah, every possible decomposition according to the rules.
Okay, I was thinking every possible decomposition of all strings. I was like, whoa.
No.
Okay.
No.
Okay.
I think that it seems like the key to like picking the right the constant
Yeah.
constant or
Yeah.
whatever
Mhm.
is really the relationship between the two elements that you're
Mhm.
computing.
Yeah.
Like I picked 0 at first and obviously it didn't
Yeah,
work.
that's the right one. Well, that is one that works.
Yeah, it's one that works.
Yeah.
Where
What's there?
0 didn't work. I mean, it didn't prove that it was not right.
No, not
So
always.
it
Because
actually
if you,
was within the
it depends on what string you pick.
because it
But
was
if you pick
actually B was
011 p plus 1 010
so
p,
it didn't work.
then if y was a single one and it was one of those 011s, if you put more ones into the string, you didn't change the number of 011 substrings. But if you remove one, then you're good. But depending on the on what y could be, you can choose a different value of I. So if it happened to be exactly that one, or a 1-1, then pump down. Otherwise, pump up, because otherwise it will have to include a 0, and then therefore that may increase the number of. No. Even if it was a single 0, it'll still cause problems. Yeah, but you can choose a different value of I depending on what the depending on what the decomposition is. So
He said one thing up and then I had to use it.
well, so do you have a?
It's like if you have your pencil up.
A funny story. Do you know what Graham's number is? It's the largest number that's ever been used in a mathematical proof. You should look up Graham's number sometime if you're curious. But it's actually been proven that if you tried to fit Graham's number into a sphere the size of your head would literally collapse into a black hole because there's so much information in one place. So, yeah, it's pretty cool. So, do you have an example of pumping? Yeah. I mean, I have one, which is this. So it's So this was from old midterm, from a previous iteration of the class. And so the idea is you have A's followed by B's, and one of two cases must happen. Either you have a really small number of A's compared to the number of B's, less than the square root of it, or you have a small number of B's compared to the number of A's. Okay? So less than the square root of the number of A's. And so this is, so claim L is not regular. And then, so if we wanted to prove this, assume it is, then as before, exists a P for L. And then, so now I need to choose a string. So now the whole art is picking the string that would actually work. So what two properties do I need of the string? At least P characters and in the language. Well, sometimes a good strategy when you have something like this is automatically make sure it has P characters right from the start and then fix it so that it's in the language. So so there are many strings that work here. But one good one is we pick P characters for A off the bat immediately. But if I did this, then no matter what the decomposition is, I still will stay in the language because the number of B's is 0, which is less than the square root of this thing. So I do need some number of B's. Well, what would be a good one to work with? Should I work with having a square root in the number of B's part, or should I go the other way? Go the other way. So what is the minimum number of B's that I need? Can I go with P squared?
P squared plus 1.
P squared plus 1, because it's strictly less than inequality. If it was less than or equal to, then you could go with P squared. You have a question? I guess not. All right. So what are all the decompositions of this string? Well, what do X and Y have to be?
Less than P.
In length, yeah, they have to be less than P in length, which means they're consisting entirely of A's. So X is A to, well, I can't use the power A here. So let's say alpha, go into Greek territory. All right, Y is A to some number beta, let's say. And Z is the rest of the string. So we have P, A to start with, minus alpha, minus beta, and then all the B's left over. You could make this informal, but I'll be formal here. Well, so the idea is if you put in at least one more A into there, which means pumping Y up once, then you'll have at a minimum P plus 1 A's, right? So therefore, P squared plus 2P plus 1 is the square of P plus 1, and that's larger than P squared plus 1, or equal to, but it's definitely not strictly less than the square root. So if we pump up, so what is x, y squared, z? Well, I'm putting an extra beta characters of A into the string, which means I have p plus beta of them and p squared plus 1 of the b's left. Didn't change them. Well, what is the only way that this string could be in the language?
If beta is equal to 0.
Even
Or
easier than that. If either of these two conditions are true, right? Do I need to check both of them? Right? It could be, like the obvious case could be wrong and the other case could be still right. So we need to check both cases. So I'm going to write this in 2 branches. So the left one's going to represent m less than square root n, and the other one's going to represent n less than square root m. Just for us to remember. So m was the number of a's. So is it true that for the left branch, p plus beta is strictly less than square root of p squared plus 1? Well, let's see.
I mean, it's not.
Well, could I square both sides and not change the inequality? Yeah, because they're integers, positive integers. So p plus beta squared less than p squared plus 1.
Yeah, no, 'cause you're gonna-
Yeah, so
P's in there.
yeah, if you simplify, you'll have 2p beta over here plus beta squared less than 1, I think. Yeah, that's true. So can that inequality be true?
No, because P has to be. Well, it could
P
only
could
be
be
true
0.
if P was 0.
Well, 0, but what is beta at least?
Oh, 1.
At least 1. Is 1 strictly less than 1? No. So this is a contradiction. But it still could be true that the second side is true. So let's check that. Is it true that p squared plus 1 is strictly less than the square root of p plus beta? It seems intuitively true that it's not true. But let's just be fully formal about this. How large can beta be? P. So this is at most the square root of 2p, because beta is at most p. Could p squared plus 1 be strictly less than the square root of roughly p? No. So therefore, this is a contradiction too. And since we got a contradiction on both sides, it can't be regular. Okay? Yeah, so in general, if you have some dependence on some run of some character and the run of some other character, then it's probably not going to be regular. Not always, but like in the case of number of 0, 1 and 1, 0 substrings, there is a dependence, but thinking of the language in a different way, it makes it regular. Well, it doesn't make it regular, is regular. But in general, if you have a dependence like this, it's not regular. Other questions? We can break here if you don't have any questions and let you guys go early.
What does lemma refer to? Do you know the pumping lemma? What is the,
Yeah.
my brain is just confused when it hears the term.
I think in the RS paper that I have on Blackboard under regular languages, I think it's proved there. Actually the bonus problem from PSET 1 about minimizing states, that equivalence relation is in the paper. It's called the Myhill-Nerode equivalence relation. But I think the pumping lemma, what actually either is in that paper, because not in the sense of proving language is not regular, but the actual positive direction that we did. We said L is regular, then then other things happen. Sometimes these languages, regular languages, are called automatic languages. I think it was called that in that paper, but I'm not exactly sure.
That's one where it was, if you have it up there, it's like the first paper written
Yeah.
on the NFAs or
Yeah,
or is it DFAs?
yeah, it's the first paper that talked about this thing called one-way automata,
Yeah.
because there are notions of DFAs or whatever that can go back and forth across their input, which are called two-way DFAs.
Go both way across the.
Yeah,
in
yes.
Which way? What does that mean?
Yeah, so like hidden in the transition function of a DFA says you move one character to the right every single time.
Right.
But you could define a model, and we're going to be talking about things called Turing machines, which are basically this and a little more, where you have the instructions say either go right or go left.
I see.
Yeah, and then there's other problems you need to worry about, but that's essentially the idea. And it's actually a research question of the fact that two-way DFAs are equivalent to one-way DFAs. But if you permit modification of the tape with this two-way DFA, it becomes much more powerful.
So if you were actually being able to go forward and backward, you have to like be aware of like how many iterations you are doing, right? Or
no, like the instruction literally just says move left, move right of where you know the neighborhood right around you, but that's it.
I see.
Yeah, just like how DFAs know their state and every state that they could go to, but that's it.
So we have like the transition function in the forward direction. So how's that notated in the reverse direction? I mean, not the reverse. But
So I'll give you a sneak peek on how we do it for Turing machines. So if suitably adapted to DFAs, it would be a transition function from Q cross sigma, and then you go to Q cross LR.
where R is the.
Yeah, so R represents moving forward one direction.
I see. That makes sense.
Yeah, so we'll be defining Turing machines very similarly to this, except we'll have an extra bit here for what you write to the tape,
Got it.
which makes
So
it
it's like
all changes everything.
Output DFA block.
Yeah, but here you're actually changing the input.
Oh right. Oh,
Yeah.
I see.
You're writing over
It's
the
like
character.
I gotcha.
Yeah. So
You're
how?
stream, you're modifying.
Yeah. How do you recognize A to the end, B to the end? Every time you see an A, cross it out. Then scan right until you see a B, cross it out. Then keep going back and forth. And if it's all X's all the way through, you're all good.
Okay, what was that solving again?
A to the end, B to the end,
Oh, A to the.
which is not regular. So writing to the tape changes everything. Yeah, we'll see
So
all that soon.
So basically, you're just capturing previous state in the like.
Essentially, yeah, but it's not knowledgeable of what it did before. It just says, okay, I see an X, I do this.
There's no backwards history. Yeah, more
Correct.
than just what immediately happened. Got it.
Other questions?
Sorry, I don't have one. I'm just very tired.
Yeah, I bet you're all tired. We can break early if you guys don't have any other questions.
Yeah.
I mean, I really want to ask a question about like problem set 2, but
Feel free to ask on Piazza, send me email, everything.
you've
Yeah,
been very responsive and thank you.
yeah.
Yeah.
Other questions?
Oh, I did post the past few days the daily exercises because I study.
Mhm.
And if I go back and do them,
So what I'm planning to do is do it in phases. So it's like, if it's like 1/5 of the way through the course or whatever, then that counts for 10 out of the 50 points, then 10, then 10, then 10, based on the days that it's done.
okay.
That's what I plan to do.
Okay, I should go back and do this.
So if we're active every several
It-
days.
It's not really specific on participation, but
Okay.
I mean, it seems like if you've been participating the whole way through, I think that's
Enough.
good. Yeah.
Do you get participation points by doing Piazza?
Yeah, that's exactly what it is.
All Piazza.
What's
Yeah,
the-
it's all
what's that
Piazza.
statement?
Metric that we can measure.
Yeah. Because if I was doing something here where I know some people and it's like this one other person I don't know, that'd be completely unfair. But this is completely unbiased.
What was your question?
Oh, it's just one.
So in theory, if I go write them all,
No,
it's
no, it's the days that you post.
specific. Oh,
Like the actual day that you actually post it.
Oh, cool. Yeah. So it doesn't matter. Going back to
Yeah. It doesn't matter what you do as long
posting one
it's
thing
the
in every
days
daily
that you post.
exercise will just be a day.
Yeah.
Not hitting every exercise.
Yeah.
So Kenneth, we should advertise the study group that we're doing, right, in this thing. Like, I mean, do we have a?
Yeah. Make a thread on Piazza.
We already do.
It's
We're,
still there. I mean, I updated when we were in the day to day, so I didn't want to really.
I mean, only a third of the class ever participated on Piazza.
was that?
Only like a third of the class participated on Piazza at all.
That's
And
because it's not clear enough that if it's just
I mentioned it in class though, so I think we're good unless there are other questions. All right.